So we've reached problem 5 and we have to find the angle between the line x minus 1 by 2 equals to y minus 8 by 3 equals to z minus 4 by 2 and the plane 4x minus 2y minus z equals to 1024.
In this question, we know the direction cosines of the line. First of all, we'll compare the line with the general symmetric form, which is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, where a, b, c are direction cosines of the line. So direction cosines, they are direction cosines only if the summation of their squares is 1. Otherwise, they are direction ratios. Here, as 2 square plus 3 square plus 2 square not equal to 1, so they are direction ratios.
Right.
So direction ratios of the line are given as 2, 3, 2. Now for the plane, by comparing with the general equation of the plane, we get ax plus by plus cz plus d equal to 0, which is similar as 4x minus 2y minus z minus 1024 equal to 0. So direction ratios of normal to the plane are 4, minus 2, minus 1. So now we'll draw the diagram and conclude what the thing is happening over here.
Okay.
So this is a plane and this is normal to the plane. This is a given line.
Right.
With direction ratios 2, 3, 2. So we need to find angle between the plane and the line, which is theta.
Mm-hmm.
So the angle between normal to the plane and the line would be pi by 2 minus theta.
Right.
So by using the dot product formula, we'll find out theta, that is cos pi by 2 minus theta equal to b dot n.
Right.
Where b gives direction of the line and n gives direction of normal to the plane.
Okay.
Of course, upon mod b mod n.
Right, but then mod n is always 1 here because n is in cap.
Correct. So here we would find out that cos pi by 2 minus theta comes out to be 2 into 4 plus 3 into minus 2 plus 2 into minus 1 upon summation of not summation, let's directly take into the account, that is 2 square plus 3 square plus 2 square power 1 by 2 into 4 square plus minus 2 whole square plus minus 1 whole square whole raised to 1 by 2, which as the numerator is 0, the whole value turns out to be 0.
Right.
Hence, also we know that cos pi by 2 minus theta is same as sin theta.
Correct.
Which is a general identity, which is given as 0 here. So this implies theta equal to 0 or pi.
Correct. So yeah, this was a fairly simple problem in terms of what it shows us. The concept here is that there's a normal to this plane, and with that normal, it is very easy for us to determine the direction ratios of that normal. Also, it is very easy for us to determine the direction ratios of a line, especially when it is written in this form. We call it the symmetric form.
Yeah.
Right.
This you need to remember that this is the symmetric form. This is the general equation of plane with a, b, c as direction ratios of the normal to the plane, and here in the line a, b and c are direction ratios of the line itself.
Right.
Here remember that these are of the normals.
Okay.
Don't confuse it with the line.
Right. So since we knew this relation, and we can always take the dot product, which is, we use the dot product formula, cos theta is equal to a dot b by mod a mod b in so many forms in coordinate geometry, and especially here. So here we did the same thing, and from then on we calculated.
And one more thing.
Exactly.
By seeing the value that 1024, don't get afraid of the problem. Like this value need not take part in the actual working of the problem.
Like when I see it, I imagine, I think of 2 raised to 10, but obviously that has nothing to do with it. So anyway, yeah, we saw that since the numerator is all all that mattered in the end. This is also a quick way to check for whether a line is parallel to a plane. Just multiply their direction ratios and add them, and
Directly-
they don't need to be cosines also actually.
Correct.
Right, because they'll be if they are, let's say, if a direction ratio is given by k into c, where c is cosine, direction cosine, then k will be same for that entire set, so it'll eventually be 0 in the end. So that's not a
Exactly.
problem because it will appear in every term. So you just need to multiply, let's say here 2 into 4 is 8 and 3 into minus 2 is minus 6. So that leaves us with 2, and obviously 2 into minus 1 is minus 2, so that leaves us with 0.
You need not worry about the denominator until and unless the numerator doesn't come out to be 0.
Okay, exactly. So again, as I said, this is a quick way to check whether a given line is parallel to a given plane. So this
exactly.
was problem 5.
Moving on to question number 6. Find the length of the perpendicular from the point 5, 4, minus 1 to the line x minus 1 by 2 is equals to y by 9 is equals to z by 5. तो हमें एक पॉइंट दिया हुआ है और एक लाइन की इक्वेशन दी हुई है, और हमें उस पॉइंट से जब हम उस लाइन पे परपेंडिकुलर गिराएंगे तो उस परपेंडिकुलर की लेंथ निकालनी है, राइट? एंड वी हैव बीन गिवन 4 ऑप्शंस. लेट्स सी द सॉल्यूशन.
Okay, so now let's work out with the solution. The equation of line is given in the symmetric form, as you can see. So there's a line whose equation is x minus 1 by 2 equal to y by 9 equal to z by 5. And there's a point not lying on the line. Let's say the point is P, which is 5, 4, minus 1. We drop a perpendicular from point P to the line. Let's say the foot of perpendicular is Q. And now we need to find length of PQ. This is what is given in the question and what is asked. Now
Right.
on the line we can define, there's a general method for this. This method eases out the problem. Now x minus 1 by 2 equal to y by 9 equal to z by 5 is the equation of line. Let's say each ratio is equal to lambda. Okay, so so that x equal to 2 lambda plus 1, y equal to 9 lambda, and z equal to 5 lambda. This represents any point, any general point on the line. There is a possibility that this point will represent Q for a certain value of lambda. Actually, this is the parametric form of the line.
Right, because Q lies on the line.
Line.
So for one particular value of lambda, Q will
represent.
obtain Q. Right,
Yes.
right, true.
So this is the parametric form of line. Now we would Q is represented as 2 lambda plus 1, 9 lambda, 5 lambda. So it is also given that PQ is perpendicular to the line. Okay, this is given. Now we know that the direction of line is defined by the direction ratios, and in the symmetric form we need to remember this, that in the symmetric form it is represented as if the line passes through the point x1, y1, z1 and is parallel to the direction AI plus BJ plus CK, then the equation of line is x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. This gives the equation of line. So directly comparing it with the given things, we would get x1, y1, z1, the point, as compare it with this equation. So x1, y1, z1 would be 1, 0, 0. So and the direction of line is given by AI plus BJ plus CK. That is, the direction ratios of line are A, B and C. This is a direct relation. If the direction is AI plus BJ plus CK, then the direction ratios of line are A, B and C.
Right.
So here it is given direction ratios as 2, 9, 5. So line is parallel to 2, 9, 5. That is 2i plus 9j plus 5k. And PQ is PQ vector. We are talking about PQ vector, which is represented by position vector of Q minus position vector of P. This is again a formula you need to remember.
Okay.
So position vector and the coordinates are nothing but the same thing, just the unit vectors are multiplied to each of the coordinates. Now PQ, the vector PQ would be given by this vector position of Q minus vector position of P, which is 2 lambda plus 1 minus this thing minus 5, that is the coordinate of P, that I, plus 9 lambda minus 4 j minus 4 j plus, you can see here this 5 lambda minus this 5 lambda minus 1, which is 5 lambda plus 1.
Right.
5 lambda plus 1 k. This is the position, this is the vector PQ. Okay, as it is given, PQ is perpendicular to the line and the line is parallel to this. So PQ dot 2i plus 9j plus 5k would turn out to be 0.
Right.
Because theta, if theta is the angle between A and B, then A dot B is represented by magnitude of A into magnitude of B into cos theta.
Right.
Here
And since here they are perpendicular, theta is 90.
theta is 90 degree.
So
Hence
cos
it turns
theta
out to
is-
be, as we have seen, PQ dot 2i plus 9j plus 5k would turn out to be 0. So we would solve this as 2 into 2 lambda minus 4 plus 9 into 9 lambda minus 4 plus 5 into 5 lambda plus 1 equals 0,
Right.
which will give, like this is 4 lambda plus 81 lambda plus 25 lambda, which is 110 lambda. This is and the constant term is minus 8 into minus 36 plus 5, which gives minus 36 minus 3, which is 39, minus 39. This is equal to 0. So lambda equal to 39 upon 110.
Right. But we need to find out the length of the perpendicular.
Yes. So
So-
this will give the point Q, which lies on the line and is the foot of perpendicular from P. So point Q comes out to be 78 upon 110, 351 upon 110 and 195 upon 110. This is just a simple arithmetic you have to perform to find out the coordinates, and it will not be a difficult job. Now length of PQ we need to find. So distance P comma Q, we would use distance formula here, which is root of 5 minus 78 by 110 whole square plus 4 minus 351 upon 110 whole square plus minus 1 minus 195 upon 110 whole square. This question may look quite complicated, but it's not that complicated. Just the values are complicated and nothing else.
The calculation is a little
Calculation is little lengthy,
laborious. Yeah, it's lengthy.
which gives 1 by 110 of root of 472 whole square plus 89 whole square plus 305 whole square. You can see that here it's this would be multiplied to this, which would give 550 minus 78, which is 472. This 440 minus 351, which is 89, and minus 110 minus 195, which would be minus 305. So this comes out to be 2109 upon 110. This is our final answer.
Right. So in this question, we saw a lot of calculations and 2 or 3 very important formulae, right?
Yes, yes.
So we saw how to convert the symmetric form into parametric form and how
Mhm.
to use it,
Yes.
right?
How?
So this was question number 5.
6.
Sorry, this was question number 6.
Okay, let's now discuss problem number 7. It states that a point A with coordinates 2, 2 lies on the curve y equal to 8 by x square. Tangent at A to the curve cuts the x-axis at B. If O is the origin, we need to find AB vector dot OB vector. We are given 4 options, so let's now proceed with the solutions.
So now let's get started. We here first need to find out where like how the curve looks like.
Okay.
We know that y equal to c by x, where c is a constant, has a curve like this, which is present only in first and third quadrants.
Okay, this is a rectangular hyperbola.
Yes.
Okay.
This is a rectangular hyperbola. So for y equal to c by x square, we see that in comparison to x square increases much rapidly as x increases.
Right.
So and x is both positive. X is positive always.
Okay.
X square is positive. Even if x is negative, x square is positive, which gives y positive always.
Okay.
So in this curve, it would be similar to the previous one, except the third quadrant part flipped up. That is,
Okay.
it would be like this. And approximately we are guessing the curve.
Right.
Okay, so let's get started with the problem. We don't need to find out the exact curve. We just need to know how approximately it will look so as to analyze the problem. Exact things would be done by derivatives and all. So we don't need to plot each and every point on the curve, just need to have an idea how it looks like.
Okay.
So the point is a 2, 2 and the curve is y equal to 8 by x square. Now the curve is like this. Point A must be somewhere, sorry, this is wrong. The curve looks like this and this.
Right.
This is point A, which is the intersection of the curve and the line y equal to x.
Okay.
This point A is 2, 2. Now we need to draw a tangent at point A to the curve, which meets x-axis at point B. Correct?
Okay.
So coordinates of B we don't know. We need to find out that. Coordinates of A we know. Now we'll find out the slope of tangent at point A to the curve. Slope, we know that slope is m, which is dy by dx
Yes. Right.
at the point 2, 2 for the line AB.
Okay.
O is given as origin. Okay. So m is dy by dx. Now y equal to 8 by x square. So y dash, which is dy by dx, which is equals 8 into minus 2 by x cube.
Right.
So m would be minus 16 upon x cube, but x equal to 2 here is given, which is minus 16 by 8, which is minus 2.
Okay.
So m is minus 2. The point on the line is 2, 2. So we know that equation of a line passing through a point with a given slope is y minus y1 equal to m times x minus x1.
Yes. Absolutely correct.
So y minus 2 would be equal to minus 2 times x minus 2, which would imply 2x plus y equal to 6. This is the equation of line AB.
Okay.
Now we know that the equation of x-axis is y equal to 0
Yeah.
and equation of y-axis is x equal to 0. So for all the points lying on x-axis, y must be 0. That's what the equation says. So as the line meets x-axis at point B, y must be 0 at that point. So putting y equal to 0 in this equation, we will get the x coordinate of point B. That would be 2xb plus 0 equal to 6, implies xb equal to 3.
Okay.
So b would come out to be 3, 0.
3, 0. Okay.
So now we know that a is somewhere here, 2, 2. So vector OA would be position vector of A minus position vector of O. But as O is origin, position vector would be 0.
Yeah.
So position vector of A is 2i plus 2j,
Yup.
and OB, as B is on x-axis, it would have only it would have only x component and y component would be 0.
Okay.
So as OB, length of OB is 3, OB vector would be 3i. So now proceeding on, we'll get OA dot OB. No, we need to find AB dot OB.
Yeah.
So AB would correspond to position vector of B minus position vector of A, which is 2i plus 2j. No, it would be 3i, which is the position vector of B, minus position vector of A, which is 2i plus 2j,
Okay.
which comes out to be I minus 2j,
Correct.
AB. Okay. Now we need to take the dot product of this and this, which would imply AB dot OB equal to 3, as I dot I is 1 and I dot J
Is 0.
is 0.
So as you have seen in this problem, the approach we followed was we drew a rough geometrical figure of the curve which was given to us, and we found out the equation of the tangent which was intersecting the curve at point A. We found out the coordinates of the point B which was lying on the x-axis, and hence we calculated the position vectors OB and AB, and then a simple scalar product gave us the correct option, which was option A in this case.
Yes, absolutely.